so you're starting with a circle with ASTC around the outside. And I want to know, which quadrant am I in if sine is greater than 0, but cosine is less than 0? There's only one quadrant where that'll be. Sine's bigger than 0, cosine's less than 0. I'd like you to highlight it super clearly in a color. And now, compare with the kid across from you. These two rows, this person straight across. Cooper, make sure you include the kid in the back. These two rows straight across. You're going to compare with the person behind you. You're going to have to do double this. Wait. No, actually, just compare the person behind you. Which quadrant are we in is what you're trying to answer here. All right. Now I'd like you to discuss what's its actual name, because a lot of you are saying C, but there's no quadrant called C.
C is all 2.
All right, so a lot of people said it was C, and that's not even a quadrant, and it's not even that quadrant at all. Because why? Well, it says cosine is less than 0, so it can't be there. Cosine's positive there, and cosine's supposed to be negative, so it can't be there. All right, and if all of them were positive, we'd be there. Sine's positive here, so there's a chance it could be there. Is cosine negative in that quadrant? Yeah, it is. So we must be there. It's in the S area, but that's not a quadrant. What quadrant is it? 2. Okay, good. Now in that quadrant, I want you to draw an ambiguous triangle. Try to make it kind of short and fat. Don't make it long and skinny. Otherwise you're saying, this side has to be really short. Just kind of make it an average looking triangle. Again, this green one would be a bad idea, because then what if I tell you that this side's actually longer than the other sides? And you'd be like, oh my gosh, my triangle is way off. But if you make it kind of ambiguous, chunky triangle, then you can label it with anything you want. So here's what we're going to label it with. Put an angle theta right there. Now, I'll remind me, there's 2 names for that angle. It's the important angle, so it's got 2 names. Jack, give me a name for that angle. It's the central angle. Good, that's one of the 2 names. And talk with the kid next to you. What's the other name? All right, a lot of you guys knew that one. It's reference. The reference angle tells you, like, if you're going to do sine, cosine, or tangent, you do it from that angle's perspective. All right. Now, the way I drew it, it kind of looks like it could be a 1, 1, root 2 triangle. So let's actually label it with that. 1, 1, root 2. Now, stop for a minute. What would that mean about the angles? Is this a 30, 60, 90 or 45, 45, 90? 45, 45, 90. All right. And then I just made the most common mistake in circle terrain. Cooper. -1. Everybody make that -1. Now, now that I've got this labeled with sides and some of the angles at least, like, I really probably should put a 45 up here to make it really clear. This is a 45, 45, 90. Now, if I asked you anything about that triangle, it would be easy. Sine, cosine, tangent. All right. So I'd like you to find out what is sine of that angle, what's cosine of that angle, and what's tangent of that angle. Write them all out. Sine, cosine, and tangent. What are they? I'm just kind of getting your brain warmed up. We're going to have a little quiz. The quiz is on the things we're talking about right now. It is formative. It is not in the summative category. If I were to read you smattering last hour's scores, and you guys are just as smart as they are. Here's a smattering. 9 out of 10, 9 out of 10, 5 out of 10. That kid learned something. That kid learned that, dude, I'm not quite getting this. 8 out of 10, 8 out of 10, 4 out of 10. Ew. And here's another 4 out of 10. Here's a 7.5 out of 10, 8 out of 10, 6 out of 10. 10 out of 10, 9 out of 10. So do you get the scores are all over the map? Some people totally understood it, but there's also a subset of people that were completely lost. It really wasn't hard. And yet there was people with pretty bad scores. So remember, this is just a little quiz to kind of make sure that you're either on it or you're not. Now, the real difference will come in this. Some kids that got a 4 out of 10 are going to actually go, oh, wait a minute, what did I do wrong? I want to learn this. I got to figure this out. And others will be like, I guess I just didn't do real good. And they move on and forget about it. And then that means their test is not going to go so well. So if you get some wrong today, you're going to want to take some time. Maybe even take some notes for yourself on like, oh, I got this, and this wrong. Maybe write out the problems. You're going to have to leave your test with me. But you might want to take some notes on what you did wrong, if you get any wrong. All right. Right now, sine of this thing is sine is opposite over hypotenuse, and opposite side here is the 1, and the hypotenuse side is the root 2. If you said 1 over root 2, you were right. Could you have rationalized it? Yes. Is it any better? No, it's not. I'd be fine with root 2 over 2, but you don't have to do that. Cosine is adjacent over hypotenuse. What's the difference? It's negative. And last but not least, TOA, opposite over adjacent. 1 over a negative 1 makes a negative 1. All right. Now we should probably do one where, like down here. First of all, do you know the name of that spot? 3 pi over 2's. And if you're trying to piece that together, you go, well, 1 pi over 2 would be here. 2 pi over 2 would be here. So then that makes this 3 pi over 2. But if I asked you for sine of 3 pi over 2, you can't make a triangle. Instead, you have to use the unit circle idea. And that reminds me to tell you that sine is like the what? The y. Cosine is like the what? X. All right, so everybody try to figure out what is the sine and the cosine of 3 pi over 2. What are those two spots? If it's the unit circle, then you know that it involves 1s and 0s, and that spot must be 0 comma negative 1. How many of you knew that there was a 0 and a negative 1 there? Okay, good. So Rhea, what's the sine? Good, because it's the y of it. And a few of you have your name tags tipped down. Can you just put it up? I know you're Mr. Good, but still, thank you. Mr. Good, can you tell me what the cosine is?
The cosine is 0.
0 is correct, because it's the x value there, and okay. All right, so next up is, are there other names for 3 pi over 2? There are. Let me just give you an example for this one, and then I'll have you do one by yourself. This could also be called negative pi over 2. Do you get that you end in the same exact spot? That's called co-terminal. If you cohabitate with somebody, you live in the same spot. If you co-terminate, you stop. Terminate means stop. You stop at the same spot. This angle stops right there, and so does the red angle. It stops right there. They're coterminal. Do you get that and that are the same place? What's another name for it? Well, I could go all the way around the circle again. That's like adding 360 or adding 2 pi. So if I add 2 pi to this, I just need a common denominator. And I'm going to put this to be a 1 to start with. And then I'm going to say, let's times it by 2 times 2. So would you agree that's like 4 pi over 2? So that you can add the 3 pi, and it would be 7 pi over 2. That's also coterminal with 3 pi over 2. All right, so that's a reminder of how that works. Everybody take this spot right here, and assume that I just made two 45-degree angles right there. Would you please name it in radians? Make it nice and clean, like it's not this, but let's say it's 4 pi over 3. Make it nice and clean so that the kid next to you can read it. And I want you to give me just one name for it first. Then we'll find more names for it. Okay? If those really just made 45-degree angles there in quadrant 4, where are you? Please turn and compare with the kid next to you. All right, so 7 pi over 4 is correct. Now, to get a different one, you can't just make this not reduced anymore. I get it, 70 pi over 40 looks different, but it's not really different. You just made it not reduced anymore. So that wouldn't be considered coterminal. Would you please find me a negative way to give this answer and a bigger way that's like 30 pi over 4? It's not that, but it's like that. Would you find me a negative and a bigger angle that coterminate? One's neg, one's huge. Find me two coterminal things. I'm pausing for a second while you try that. Okay, so for the negative one, it's pretty simple. You just go this way, and it's still pi over 4s, so I'd say negative pi over 4. And then to get the huge one, I would take my 7 pi over 4, and I would add 2 pi to it. Because you're just going to go this way in the first place, and then you go all the way around a whole nother circle, which is 2 pi. So what is 7 pi over 4 plus 2 pi over 1? I'm timesing by 4 and 4 to get a common denominator. Now I've got 8 pi over 4, which is the same as 2 pi, but it adds better. 8 and the 7 makes 15 pi over 4. Who had 15 pi over 4? Good. All right, that's called coterminal angles. Another important concept is, what if I give you sides that aren't the common ones? Like, would you agree if I said 1, 2, and the square root of 3, you'd know it. But if I said 1 and 5, you wouldn't know it. Nobody knows that one by heart. But you can get all three sides because it's a right triangle. And the way we would tell you this would be to say sine of some angle is 1 over 5. Do you get how I gave you the opposite and the hypotenuse? So if I give you a calculator, I could ask you what the angle is. You could do inverse sine and get the angle. But there's no calculators for this quiz, and there's no calculators for this test. Okay? So what would we ask you? What's cosine of the angle? And what does that make you do? It makes you figure out the adjacent side. Because cosine is ka, adjacent over hypotenuse. So everybody figure that one out. I'm going to pause for a second while you find cosine of that angle. Third side of a right triangle. So there's a much faster way than the Pythagorean theorem. I recommend that you just memorize that this is always the square root of, and the two numbers squared, 25, and 1 squared is 1. And then if you're on the longest side, which we're not, you would add them. But if we're not on the longest side, we subtract them. So a square root of 24. But can you leave it as a square root of 24? Technically, no. You know why? Because it goes root 4 and root 6, which is 2 root 6. That is simpler, and you have to always reduce if you can. So now change your final answer and tell me what's cosine. Lily, what'd you get for cosine then?
That'd be 1 over square 2 square root 6.
I believe cosine is adjacent over hypotenuse. Isn't the adjacent side from the reference angle 2 root 6?
2 root 6 over 5.
There you go, 2 root 6 over 5. Okay, any questions about that one? All right. I need to know, be honest, how many of you got that one right? That's most, but not all. We're going to do one more like that. What if I said cosine of some angle is 3/4? Sine of the angle is also positive. That tells you now, you know two of the functions, you'll know which quadrant you have to be in. Then you can draw it and tell me what's tangent of the angle. Always draw the picture. And always put ASTC on it because that'll help you narrow it down to which quadrant you have to be in. Draw it, figure out that third side, figure out the answer. And in a moment, I'll have you compare it with the kid next to you. Okay, let's see how you did. First off, since cosine is positive and sine is positive, you had to be in the first quadrant because that's the only place where they're all positive. And we didn't need all of them to be positive, but to get both cosine and sine positive, that's where you were. And then cosine of this reference angle is adjacent over hypotenuse. And do we know that one by heart? No, it's not the 3, 4, 5 triangle. So this must be square root of 16 and 9. And this is the kind where you subtract them. Okay. So what do we get for that last side?
Square root of 7.
Square root of 7, and does that reduce? No, so then you can leave it as square root of 7. And then tangent is TOA, opposite over adjacent. Square root of 7 over 3. Who had that one right? Okay, cool. Any questions? All right, then there's one more thing that's a lot like this. I see some questions and like concerns. Anybody want to ask? Yes.
How'd you get 16 minus 9?
Okay, so I always, for the third side, I think you had just stepped out to the bathroom when I reminded them, square root of, and then you take this one squared and that one squared. And if you're on the longest side, you add them. And if you're not on the longest side, you subtract them. Okay, so this is 16, and 3 squared is 9, and I subtract them, and that's how I got the square root of 7. It could be used by a squared plus b squared equals c squared. It's just a slow, clunky way to do it. But since it's a right triangle, that's really what we're doing, just faster version of the Pythagorean. Okay, so that's very similar to this one. Everybody write this down. Sine of this angle is 1 over x. Is the first time where you've ever done one where you didn't know the side and they called it x. But in my opinion, it's exactly like the last one you just did. It really is. Always do the ones with variables in the first quadrant, because it's true that you could have a negative number and therefore it would put you in a different quadrant, but your answer will always be the same. So keep your life simple and just draw yourself a triangle right here. And you do know two sides of the triangle. It's just that one of the signs is called x. So sine is opposite over hypotenuse, and then I can do my third side, which is square root of, just taught you how to do this, can you do it? X squared and 1 squared is 1, of course, and then minus, very good. Now some kids think that they can do that square root. They think, oh, the answer to that is x plus 1. No, it's not. It doesn't work. Okay, so you can't just figure out the square root. You'll leave it that way. And then what we'd ask you is something like, what's tangent of the angle? Well, you'll need this third side. That's the whole point of the problem, is can the kid figure out the third side? So then this is easy. TOA, opposite over adjacent, 1 over square root of x squared minus 1. And don't try to simplify these. For those that still think the answer is x plus 1 or x minus 1, it's not. I can just prove it to you. What if I had the square root of 9 minus 1? Okay. Square root of 9 minus 1 is like square root of 8. And is that the same as 3 minus 1, which is like 2? No. You can't simplify these like you might think you could. Yes?
Because the opposite side is a 1, isn't this a 30, 60, 90?
No, just because that's 1 doesn't make it a 30, 60, 90. I mean, I know of the common ones we have memorized, it's 1, and then 2, and then square root of 3. But just from knowing one side is 1, I mean, like I can draw a triangle that has a side of 1 here. Isn't there 2 different options? Couldn't it be 1, 2, square root of 3? Couldn't it be 1, 1, square root of 2? You know what I mean? And couldn't it also just be that that side's 1 and this side's actually super long? Like, there's no reason it has to be, you know, this could be 10 and that could be 1. So, no, you can't just assume that this triangle must be one of the ones you've memorized. All right, so let's do one just like that. I'd like you to try this one now. Cosine of some angle is equal to 1 over x. Figure out the sine of that angle. Always do these in quadrant 1. And the way I start every problem at this, once we're at this level, is I always put the ASTC on there, because sometimes it'll really help. Other times it doesn't, but just kind of a good base graph. Let's see, draw it here. You don't know how long x is, so don't just assume, oh, x has to be this long. You don't know. We don't know how long it is. It's just called x. All right, I'm going to pause for a second while you try to answer the question, what would sine of this be? If you draw the triangle and you got all the angles that you can and all the sides that you can, then the answer is usually easy at the end. Listen up to how this one would go. Cosine is adjacent over hypotenuse, and then this last side would be square root of x squared and 1 squared. And since it's not the longest side, it's still a minus. That looks a lot like last time. So now, if I want the sine of this, it would be the opposite over the hypotenuse. From this angle's perspective, this one right here is our opposite over this one, is the hypotenuse. So square root of x squared minus 1, which you don't try to simplify, over x. Who had that one right? Cool. Now, in a moment, you're going to start this quiz. Some of you will literally finish in 5 minutes. It's that easy. And you heard me, though. I read off the scores. Some kids are going to only get half of them right because they really don't understand this. But when you're done, your Schoology quiz may be taken out. So right now, you can put your iPads away. No calculators. But then there's a Schoology quiz for homework. It's like 5 questions. So you're going to basically finish this in class. You have to. And then we grade it in class. So if you don't understand at the end and you're like, I don't have time, that means you don't know how to do it. Because if you know how to do it, it takes 5 minutes. And then it might take a little longer than 5 minutes, but we have way more than that. All right. If you have extended time, this is not a test. It's homework. But I understand if you have extended time, you may step in the hallway when we grade it, and then I'll grade yours personally. All right. Okay. That's all I have for you for the video for today, and good luck on the quiz. Schoology quiz after.